Welcome back, everybody. So this lesson, we are going to study some specific ways that we can design a study. So we've already have a foundation on what variables are, different types of variables that we can gather data on. And we've talked about ways to get samples. But now there's some options available to us as far as what type of study we want to run and the type of analysis we want to use on that data. Okay, so we want to start talking about the difference between what's called an observational study and an experimental study. So these have a very important difference in them. An observational study has the researcher just watching events unfold, typically in their natural environment, without trying to control the conditions or the environment, right? The researcher is an outside observer, just peeking in and seeing what happens. So for an observational study, I suppose we can write that out. The researcher is an observer. Without trying to control the conditions or the environment. That was an N. Or the environment. So research has no control. So an example of an observational study would be something that I did way back in the day when I was taking driver's education. I remember one of our assignments was to sit at an intersection and just record for each car, record whether it stopped completely at the stop sign or not. Okay, so I am not influencing the cars at all. They're going about their business. I'm not controlling any of their business at all. Okay, just observing them in their natural state, doing what it is they want to be doing. And then I'm just gathering data based on my observations. All right, so that's an option. Another option for a study is to actually conduct an experimental study. The experiment is different in that the researcher does control. I'm sorry, I wrote control twice. The researcher does control conditions and environment, which can be necessary if you want to eliminate or minimize the chance of confounding variables, of other things explaining the change in your response variable or whatever it is, other than what you are hoping will explain that change. So again, an experiment, the researcher determines the effects of some treatment while carefully controlling the conditions and environment. Okay, so the biggest difference then is the researcher's control. An observational study, the researcher does not have any control over the conditions and environment, just observing events in their natural setting. The experimental study, the researcher does control, very carefully controls conditions in the environment so that the most likely explanation for the results is that specific treatment that they are exploring and studying. Okay, and there's probably subsets of these, and there's other types of studies. A survey study is a little bit different from both of these, right? You give someone a survey, they fill it out, and then you just analyze that data. An experimental study typically has a control group and what's called a treatment group. Okay, not all of them, but most tend to have a control group and a treatment group. The control group doesn't get the treatment, and you observe what happens to them. The treatment group obviously gets the treatment. You observe what happens to them to see if any differences occur between the control and the treatment groups. Okay, the first type of, now we're going to talk about several types of just the experiment version of this. You can have a completely randomized experiment. So for a completely randomized experiment, I'm probably not going to write these definitions up in words, but I'm going to draw you some pictures, okay? So a completely randomized experiment has the entire sample in one group. So remember, this is not sampling. We already have our sample. Now we're deciding what to do with our sample. Okay, how do we assign members of our sample to the control group or the treatment group? For this one, you take the entire sample and you split them up. Use typically some method of randomness, use a random number generator or something, and just take the one group and split it up into the control and the treatment groups. Okay. Again, randomized is best. You want to minimize bias in this selection. You don't want to choose just all the smart people for the treatment group because they're going to perform better on the test anyway, right? Anyway, so you don't want bias there, so you need to randomly assign these. As we jump to the next one, a blocked experiment is different in that you break the sample up into subgroups. Group 1, Group 2, Group 3, okay? So maybe you're grouping them by their past performance levels in classes, or maybe by their GPA, right? We have our A and B students in the first group, our C and D students in the second group, our failing students in the third group, or something like that. And now from each of those groups, we randomly assign the members to the control or the treatment group. And that essentially makes sure that each of those groups are represented appropriately in both the control and the treatment. All right, so, and the grouping, how you break them up into groups, again, will depend on your research question. That pretty much drives the whole study design, your research question, whatever it is you're trying to figure out. So those groups, again, could be grades. They could be experience with a specific type of mathematics, or how many years they've been taking art classes. Something will allow you to break them up into groups. Okay, and so even a finer way of grouping is to take the entire sample, and based on one or even more characteristics, you're going to pair off all the members of your sample. Okay, so each pair is going to share or be very, very similar on whatever characteristics you're interested in. Okay, so going to be a lot more, right? There's going to be a lot of pairs if your sample is going to be large enough to make a difference. All right. So we break the sample up into pairs, and guess what? One person from each pair goes to the control, the other one goes to the treatment. And again, this basically serves to make the control group and the treatment group as similar as possible. That way, the comparison between them is much stronger. Okay. So, completely random, one group, split it up into control and treatment. Blocked experiment, split the entire sample up into subgroups, and then divide each subgroup into a control and treatment. And then matched pairs, even more groupings, right? You're going to group them in twos. Everyone in your sample in twos based on the characteristics that are shared. And one of each pair goes to the control, one of each goes to the treatment. Does that make sense for the experiments? So not too bad. I really like the visual version of those. You can write what I set out in words. Maybe that's a good exercise for you to write that out in words, what the difference is. But in my thinking, a picture's worth 1,000 words. Yep. Okay, so we already talked about the difference between the control and the treatment, right? So the control doesn't receive the treatment group does. And again, that's so that we can compare the results from those that had the treatment to the results of those that didn't, to see if any differences really did occur, any significant differences. Now, if you want to further eliminate bias, so if a researcher is splitting people up into groups, hopefully they're doing it randomly, but there is the chance, more of a chance, that the researcher may be biased towards one group or the other. Maybe they're researching this new cutting-edge teaching strategy that they helped develop. They really want this to be shown as to work well. Okay, so maybe some bias might happen when they're assigning their sample to the control or the treatment group because they want their treatment group to perform better, right? Well, one way to eliminate that bias, well, and on the other hand, even students could have a bias, right? If they're your students, they go into the treatment, they know that you're expecting them to perform well because you really want this to work, and so they do better. Okay, to eliminate that, we can use a blind study. All right, so a single blind study, so just a blind study, the participants don't know if they're in the control or the treatment. Okay, so typically if it's like a medication study, that means the treatment group would get the actual medication, but the control group would get what's called a placebo, which looks like the treatment, but it's actually inert. Okay, it doesn't do anything. Okay, so that makes sense. So now participant bias won't happen. Okay, and you get into things like the placebo effect. Well, if the participants think they're getting the medicine, so they get better even though they didn't really get the medicine. Okay, but this makes it so that the participants don't know which one they are. Okay, it makes it a little bit even more unbiased. Now, if we make it a double-blind study, the difference is that the participants and the researcher don't know which group everyone's in. Okay, So now the researcher bias is less likely to happen as well. They don't know who's getting the treatment, so they don't know who to be biased towards, right? So clever way, each level of this blinding of a study just takes a little bit more work and probably a little bit more manpower to make it all work right. But if you can afford the time and the effort to make it happen, it does minimize bias, which is, again, the goal. Do the best you can to minimize bias. So don't know who is in the control or the treatment. Perfect. So then we have blind and double blind. We talked about what a placebo is. And so we only have a couple more things in this lesson left. First, typically in a study, you have two types of variables that are of interest. You have the explanatory variable, that's often referred to as the independent variable, and you have the response variable, which is the dependent variable. Okay, so the explanatory variable in an experiment is typically the treatment. Right? That's what is going to explain the results. Your response variable is whatever you're using to gauge change, to gain success or failure. If we're researching stats students and how well a new teaching strategy helps them on the final exam, okay, now I have my two variables. The treatment is the new teaching strategy. What's the response variable? What's the dependent variable? That would be the final exam, okay? The instrument that I'm using to measure this change. Does that make sense? So both of those, again, are typically in every experiment, okay? So this is, let's write it as the variable being influenced. Okay, there is an L in there somewhere. Influenced by the explanatory variable. So the naming will help you understand. The explanatory variable explains what happens. The response variable responds to whatever the treatment was, responds to that explanatory variable, or the lack of response is also a thing, right? So again, the explanatory variable is your treatment. Whatever it is you're trying to find the effectiveness of or the influence of, the response variable is the one being influenced by that explanatory variable, by that treatment. So ideally, if you're using a good experiment, the researcher has controlled the environment such that the most likely explanation for changes in the response variable is that treatment that they're interested in. Now, there could be what's called confounding or lurking variables. If you have it controlled well enough, the confounding and lurking variables provide an alternative explanation. Okay, so we are hoping that the treatment is what explains any change in the response variable. A lurking variable could provide alternative explanations. Provides alternative explanation for your changes in the response variable. This is other than the treatment that you were hoping were causing those changes. All right, so what's an example? So if I was talking, if we were doing that stat study that I told you about, we're researching the effects of this new teaching strategy on final exam scores in a stats class. Well, so I give the teaching method to my treatment group, and it turns out that treatment group did perform better on the final exam than the control group. Well, can you think of any other things or any other explanations for why that treatment group could have performed better? Well, maybe that class, that treatment group, they had regular study sessions. They all got along really well. They met as study groups, and because they had these very elaborate study sessions, they were able to brainstorm ideas back and forth, whereas the people in the control group didn't have quite the same relationship. Now it's because of the study group that treatment group performed better, right? Perhaps the makeup of the students. Oftentimes, because of schedules, you get more of a specific student in one class than another class. So maybe our control group actually ended up having more, I don't know, musicians in it. Not that musicians can't be equally well at stats, but maybe there's a difference between how musicians would perform and the other one was all math and science majors. So it makes sense math and science majors may be getting this a little bit better. Okay, so again, a confounding or lurking variable provides an alternative explanation for the results. Okay, awesome. So there's a decent snapshot of different types of studies you can do and the different types of experiments specifically that you can use for a study. You guys are now armed and dangerous, ready to design your own, right? Good luck with your study design, and I will see you later.